Good morning, everyone. We'll start with the first talk of the day after the opening by Holger. Thank you, by the way. And this will be HTTP All the Things by Nick. Enjoy.
Thank you. So, those of you who have been here in one of the recent years will notice something is different. There's another title on my first slide. You know the three traditions of Debian reunion Hamburg. It's Mao in the kitchen, it's cheese and wine in the other kitchen, and Nick giving a talk on how the new Debian Edu approach will be ready this year. This time I decided to make a more technical talk explaining the workings of some things and how this developed into a general idea of how to do sort of enterprise device management in a more modern way. So imagine you're working in a company and all your team members are actually at the beach and not even the IT department notices. Wouldn't that be great? No one knows you're a dog and sitting on the beach when working. Okay, so let's close up on this thought and what's the technical issues and ideas behind that. To do that, first let's look into the average corporate basement. We have our nice little Debian network. No Windows here for now, just nice Linux machines. And the traditional approach when we design a corporate network is we have some infrastructure in the basement and quite big collection of protocols that is used. There's the traditional protocols, LDAP for keeping data about users, groups, devices, and all that. Kerberos as an approach to passwordless authentication and single sign-on, NFS for file servers, and you name it. And I will not go into too much detail here, but some of this is, let's say, well established and was developed for a long time. But that it was developed for a long time means that even if we have an LDAP directory, which counts as already a quite modern approach, once we try to do some more advanced thing, we get to a point where we are doing such things as NIS, Yellow Pages, net groups through LDAP. And things get somewhat dusty quite fast. So the good thing is all this is rock solid. LDAP and Kerberos are very well established protocols. They have high levels of security. Kerberos is difficult to get right. There are ZVEs all over the place and they keep coming in, and both MIT and what's the other one called? Forgot it. Heimdall, thank you. MIT and Heimdall Kerberos are in focus for security research, and they there is a new ZVE dropped every now and then, and there's no point at which this will stop because it's really quite complex. But it's also still high security and has a very high level of compatibility. Everyone supports it. Everyone who designs enterprise networks knows it. It's basically established and very solid. And what about the tech giants? This is all hobbyist networks. No professional person would ever use Linux, right? So the tech giants, looking at them, Active Directory. So what is this? It's LDAP and Kerberos and DNS, but LDAP, basically LDAP and Kerberos. So obviously we are doing everything right here by also using this protocol stack. But there are some minor issues. It's all assorted protocols based on TCP and UDP, which sort of works great in a local network until all firewall admins go on holiday. And where it gets harder is in bring your own device scenarios. So I experienced a constant discussion between people wanting centrally managed corporate networks, centrally managed corporate devices, and allowing people to bring their own devices to work. And that's never easy to solve, as the experience shows. And remote work is somewhat hard. We can, of course, establish VPN systems. That's all possible, of course. There's nothing that is really largely unsolved here. But VPNs do have some drawbacks. They might not be available early enough because, we want to log in on a device, and if everything works bad, then we need credentials to get into the VPN, to use credentials to log in. We have long-standing connections. We need to keep a tunnel open mostly, and ports might not be reachable. We are at the beach, we are in some hotel, we are on Deutsche Bahn, you know, who knows? And that particular VPN connection just does not work. And we can then call Citrix and get a Citrix VPN in the browser, but nobody really wants that. Okay, so what's the vision here? It shouldn't matter where we work, it shouldn't matter on what kind of device we work, and it shouldn't matter how good the internet connection is. And the more radical idea is we should not really hardly depend on any particular network setup. We should be able to treat the cafe Wi-Fi just the same as the office Wi-Fi, and the office should just be another beach or another cafe where we get some sort of access to the internet. But it doesn't really matter what IP address we get assigned. It doesn't really all that basic networking stuff should not matter, so that we can actually look at the beach setup just the same way as the office setup. Okay, so let's build it, I'd say. And now here's the good news. If you liked systemd, I am now moving systemd into the cloud. Anyone with tomatoes and raw eggs around? No? Okay. So let's raise our heads and move our eyes from the basement into the clouds. Cloud obviously is the same marketing bullshit here as it is everywhere. But the thing is, a lot is moving onto the web. Office applications are moving onto the web. Desktops are trying to be moved onto the web and into the browser every now and then. The web has a lot of very helpful standards. Yeah? Especially single sign-on is a resolved issue on the web. OpenID Connect works great. There are few people and few services really implementing it the way it should be to work great, but the protocol is there and waiting to be used in a meaningful way. The nice thing about web technology is that most of the time we are only doing very short-lived HTTP requests, and once we are done with this request, we're done. And short-lived HTTP requests basically work all the time, even on Deutsche Bahn. The question now is, how do we get devices onto the web? And so let's first look at what we need. We need some sort of identity management. We need device management and access management. And what would be nice is if we could also get some basic configuration and software management out of that. And all of that location independent. We do not care whether we are in an office or in a cafe or on a train. And yeah, the technical limitations we want to impose on the system are we only want to use HTTP, nothing else than, oh yeah, of course, HTTP over TLS, HTTPS, but we do not want to use anything except short-lived HTTP requests. And only standard protocols. We do not want to reinvent the wheel, mostly. We want to use protocols that are already there and on the web, in web terms, as well established as LDAP and Kerberos. Single sign-on would be a very cool thing. And if we could get some privacy benefits out of this, this would rock even more. Which is the point at which I'd like to introduce you to WebEDM. Don't care about this backlog thing. I can't explain what it is and don't even know myself. Just a fancy name I came up with in contrast to Azure. So here's the idea of the new design of the enterprise network. We're basically moving everything onto HTTP and the OpenID Connect standard. So why is that? OpenID Connect is the most recent OpenID Connect standard. It's based on OAuth. It has not so much to do with the traditional OpenID, but it is, if you know OAuth, this is a system where you can ask an authentication server to issue a token that you can then use to request authorization for other services. A bit, not too much technically, but a bit like Kerberos tickets work as well. And OpenID Connect puts an identity layer on top of that, allowing us to retrieve cryptographically signed tokens that prove our identity. So this gets even closer to Kerberos here. And basically this is what works in the background if you log into some site against a Keycloak service or against Microsoft 365 or your Google account or GitHub, Apple ID or Debian Salsa. We get a reusable token. In this case, this is specified as a JavaScript web token, which is more or less a JSON object that is cryptographically signed. And yeah, we can use this token and pass it around once we got it, and we can pass it on to the Element application for a matrix chat or to the Nextcloud desktop application to get file syncing to work and all of that nice stuff. Because all these apps that are based on web applications in the background, they basically all use OpenID Connect. So if we get to the place where we can log into our desktop using OpenID Connect, we then get a token to do single sign-on for other services as well. Yeah, so here as a conclusion, a list of some ingredients. We need some sort of web service that exposes OpenID Connect and ideally a REST API where we can query a list of users. Knowing who I am is nice, but there are scenarios where we still want to know what other users exist and what groups exist and stuff like that. And this service should expose JSON user records and JSON group records. What this is, I will talk about in a minute. We need a software package that consumes this API on the local machine. This is what I call WebIDM D, which works closely together with systemd userdbd. Has anyone here heard of systemd user dbd? Oh, okay. So I was surprised. This is my excuse for this for the Debian Edu and Alexis demo with using this system not being finished this year, because somewhere at 75% of implementation, I found out that most of the work has already been done in systemd. Systemd has this user dbd service, which is a multiplexing service that already exposes a JSON-based API where you can plug a provider into, and it makes data from this provider magically appear through NSS and all that stuff as system users and system groups. This is how systemd homed works. If this is a new kind of managing home areas and users in systemd terms. No one really uses that, but it's Leonard Pettering's idea of how to do home directories and portable home directories. Has some nice things. But the main part we need here is user dbd, because we can plug another system in there, let this system talk to a web service, and expose the information through a system that is has already been there the whole time. We need another part for Palm. Palm is a really ancient system, but after some discussion also on systemd mailing lists, we cannot really get rid of Palm, and I don't want to get rid of anything actually, but Palm has really major drawbacks. It's both NSS and Palm are technically not on par with current software engineering approaches, because they load shared libraries into a single-threaded application, and they do fancy re-entrant stuff to... I don't get into this here. It's hard to do asynchronous stuff with them. This not entirely translated bullet point at the bottom. We need, we can use systemd homed, so we can decouple our local user IDs and group IDs from the IDs used in the web provider. So what does this web itemd do? It fetches and manages OIDC tokens. So when I log into my system, there can be several approaches to do that. But at the end, it fetches an OIDC token and persists it in some way and can make it available to other applications. It fetches and caches these user and group records. And the nice thing here is that user dbd already takes care of also letting us store resource limits like quotas, memory limits, locale settings, environment variables for the session, all in a web-compatible JSON format. And it will make sure to place all the stuff in the locations where the system the user session then expects them to be. So it can WebIDMD shall be able to perform OIDC flows in cooperation with a login greeter. Greeter meaning the thing that you actually see when starting a desktop session. You might have SDDM, GDM, LightDM, some sort of display manager, and what it does to provide you the graphical login is it runs a greeter program that normally asks you for a username and password, which also works when we use OpenID Connect. There's a frowned upon OpenID Connect flow that uses traditional usernames and passwords, but the more modern flows use other approaches like showing a web page and letting you log in on the provider itself. So we need some cooperation between WebIDMD and the greeter program to do that sort of OIDC flow, which for those who carefully listened, and I know at least Yuri carefully listened when I talked about this yesterday, that this of course means we get into trouble when someone wants to log in on a device that is not online. But that's solvable. So in graphical terms, this is somewhat how it looks. Everything except the web item row is already there. We get things talking to UserDBD, and UserDBD then takes care of hooking into web item, and web item doing all the heavy lifting to talk to a web application. And I again placed some examples at the bottom. We can, for example, consume users and groups from the Alexis school information system or from Azure AD actually. So yes, we get a replacement for Samba, which can use Azure AD here for free. We can also log into GitLab. So we could build systems that allow login with any account from Debian Salsa if we wanted to do this for something. For some reasons, then this is also something that could be done. From a system administrator's point of view, this is what I wanted to look. We install a package and we tell it to enroll, for example, into salsa.debian.org as an OIDC client. At this point, something has to happen to actually get hold of client credentials for the OpenID Connect, but that's a somewhat different topic here. And after that, ideally, user login and user listing and all that we expect in a Unix system is supposed to start working. As I said, UserDBD can already handle this sort of backend agnostic user record things. It's basically zero configuration from there, because any Debian system using systemd already has everything in place to consume user records from systemd UserDBD, which, as it stands, simply does nothing. But once we start plugging things into it, then it starts appearing and working in the system. So what do the tech giants do? So what's Azure? What's Active Directory? It's LDAP and Kerberos. And now you see there's this Azure AD thing. Microsoft wants you to not run a Windows server in your basement anymore. They want you to use their web service, their cloud offers. And if you use the cloud offer, then on Azure, which is called Azure Active Directory, you find that what they actually do is OIDC and the REST API. They chose a somewhat different approach because their native technology to do user records is Active Directory LDAP. So they just encode the ASN1 stuff from LDAP into JSON objects and pass them around, okay. But apart from that, basically what they do is exactly the same thing. So if we use the same stack, we did everything, right? Or not, we will see. Okay, so there are a few other things I already tried. One thing is webmiltd, hooking postfix or xsim directly into this setup to get mail addresses and alias resolution and all that working against the web API. This is actually running in production at TechIts for a year now. Then there is Debian, which is a PHY config-based, thanks Thomas, with profiles for desktops, tablets, and the idea is that, no, I will get to the idea later. And the core shall be an open API specification, which is already already there. So this is the open API specification that web item relies upon to retrieve user information after getting a token, and this is basically the schema that systemd user DBD already uses. So there's, if you like systemd and if you embrace systemd, then there's nothing really new about that. By the way, of course, GitLab or Microsoft 365 will not implement this JSON schema, but WebItem can handle that. Can provide a JQ program. JSON query is a library for transforming JSON, and you can provide any sort of JQ transformation program to transform whatever the web backend exposes into such a user record. Okay, so where did we get from? The idea was we wanted to use Alexis, the school information system. Here's a somewhat aged screenshot from Alexis. It's a school information system. It's showing a classic timetable here. But Alexis is far more than that. It's supposed to be a central management system for all organizational information in a school. And it can already manage matrix spaces and rooms, and we are working on centrally managing Moodle courses and all that organizational stuff. And the idea is that Alexis, which already manages the basic personal information about people in the school, to use this also as the central backend for user and group information for the school network and for school devices. And at some point, maybe to have it as the management application for Debian Edu, which was not yet finally decided though. So we want to get user management and device management directly in Alexis. We want to get immediately usable devices. So we hand out a tablet or a laptop or whatever to a student. They log in using their Alexis credentials. And although they never used this device before, they get a working desktop, including single sign-on to the Element desktop application for the chat, and to Nextcloud and Nextcloud desktop to get file syncing and whatever to work out of the box on a freshly used device. This is the goal where we want to get here. We want devices to be directly managed in Alexis, and school admins also shall get a single installation image. That's the reason for this new file config space that's being developed. What we basically want to do is we want in the place where admins can manage the devices for their school in Alexis. We want them to have a download link for an installation image, and they get a small ISO file. This is prepared to hook into Alexis, and when they boot some device from that to install Debian on it, they just get the possibility to enter the domain of their Alexis instance, their admin or user credentials. And then they say, I want this is a tablet, I want to install a tablet system or a laptop, traditional laptop installation, or a replica of Alexis for my local network, or whatever. And from there it shall be fully automatic. and everything else shall be drawn from the Alexis database already. Yeah, so for Debian Edu, which is Debian's pure blend for school networks, yeah, we or more or less, I am trying to get Alexis to a point where it can replace Goza as a management front end, which would mean that we most importantly, get a more modern, more polished management front end for users and groups and devices in Debian Edu. And also that schools who use Debian Edu get a school information system that is ready to use, free and gratis on top. At some point, this could also maybe migrate to web items, so we could get rid of LDAP and Kerberos, which is very much frowned upon by a part of the community for well understandable reasons. But this all requires to have a prototype to work with and to try out, which will certainly be ready sometime this year. In case there are people here with too much free time, there are things where we could need help. So first, for the educational stuff, TechIds is currently the biggest driving force in this topic because we are, depending on from where you look at it, TechIds, which is the free software youth organization, we are more or less a very decentral school. And we really want device management and children using devices in workshops and have their files synchronized and all that stuff to work in a really decentral fashion. So TechIds is the main driving force here. If you don't have too much time, but you happen to have too much money or know someone who has too much money, we can really use funding. We really critically need funding for the Alexis project. And if you happen to also have too much free time and a very high level of pain tolerance, then we need people to do packaging of an astounding amount of Node.js packages. There are also some Python dependencies left that need to be packaged or updated. At this point, thanks a lot to Edward Betts, who is not here this year, I think. He last time he jumped in after my last year's talk, and in the time after that, he did a lot of work packaging Python dependencies for Alexis. So thanks here again. There are still some left, and some need to be updated because they sort of bit rotted. And the much bigger part here is that we also need many JavaScript dependencies packaged now. And there are also some engineering tasks. We need to look into how a migration from Goza to Alexis could be possible, excluding or including the migration away from LDAP. This is something that can only be decided after trying it in practice. But before that, we need people figuring out how it could best be done in theory. Yeah, if you're not so much into education, there's also the enterprise context. I am doing a lot of innovational work with my company Velocitux. There's not much you can do there, but discussion and critical questions are welcome. Yes, the obvious parts, how do you handle caching, but what about not using systemd? All right, thank you, but there are many other discussion topics that can be very helpful here. In particular, still there are some engineering tasks. So how do we actually solve caching? Yes, I am very aware that caching and offline use is a big issue here. But looking at the tech giants, they did solve it. So we can maybe look into how they did that, or we can come up with own fancy ideas on how to solve this issue. Then there's this topic of how to design an asynchronous varlink API for Palm. So the same thing that works for NSS and user records now, how do we make this work for the actual authentication? This does work, but it's cumbersome because Palm is not, as I said, not really compatible with asynchronous software approaches. If you're into development, someone could also implement a reference backend for the web item API, preferably in Rust. The thing here is I am currently both figuring out how it should work and then learning Rust because I really want to do it in Rust. Don't ask me why. And both is a bit too much, so some help with figuring out the technical Rusty part here would also be much appreciated. Right, so some more information can be found here. There's for the backblow thing, there's not much more than the OpenAPI specification. For Alexis, if you're interested in what this thing can do apart from future device management, you will find this on the Alexis website, or can talk to Jonathan at the right there, this Jonathan and me, while we are still here. We'll leave after the group photo. And apart from that, thanks for bearing with my idea of systemd as a service.
Thank you, Nick. Are there any questions in the audience?
Yes, thanks for the excellent talk. I didn't quite get, when I log into a device, you said you want to use systemd homd for mounting the home directory. Will this be local storage or will this be some cloud storage?
That really depends on the setup. The thing here is where we want to get is that it doesn't matter which device I use, but it doesn't matter where I work either. So the obvious good rock-solid solution of mounting a home directory through NFS or something will not really work out here. So it will probably go in the direction of having a local home directory and making the synchronization to, for example, Nextcloud 0 configuration. There are other approaches, maybe hybrid approaches where you can use a local caching file server if you are in the office or something. We will see. The main reason for using systemd homd is that it can handle assignment of dynamic user IDs, which is not so much to do with home directories, but then systemd homd has not so much to do with home directories, but more with providing user records as well. Yeah.
Good.
Can you comment on how much you believe these systems, or particularly, I guess, Alexis, is used outside of Germany? Because I have sometimes the feeling that Germany is way ahead in open source at schools than at least some neighboring countries.
That's a difficult question. Just like with Debian Edu or Debian itself, we have no dependable telemetry. We know of some schools who are using Alexis, managing it themselves because they have some nerdy computer science teachers who do it. And there's one Landkreis, one region in the east of Germany, who is also throwing a lot of money into the project and contribute to developing it into the central school management solution in the whole region. That's what I know.
What I do not understand, even if we solve the home directory file server thing, if I want to be independent of the devices that I use, what about my settings in the web browser or the configuration of my LibreOffice? If I have different devices where different versions of the software is running, does this solve? Is it solvable in a way, or is this another problem?
This is this is solvable. Yeah. So first, synchronize the whole home directory, but this does not work. I tried this for 10 years in several setups. This does not work. There is one other approach, but if I offer this approach now, you will force me out of the building, everyone here. Probably not everyone. Because there is this more or less frowned upon thing in Debian circles called Flatpak. And Flatpak has some technological benefits, including having the application storage and the part of the home directory used by this application nicely bundled into a sort of container, so we could actually push and pull that thing.
Okay, but
yes, there are approaches, but it is a hard issue.
But if I use different devices or get a new device from my school and I use different versions of program, this might become a problem, because then I store new settings and then I call an older version of the program with new settings that are unknown.
Yeah.
This has to be solved to be independent of the device.
Independent of the device does not necessarily mean independent of who and what and how manages the device. So there should be obviously a requirement to keep the software used on the devices at least reasonably in sync. Okay. And Flatpak already has a mechanism to move your data for selected applications onto a USB stick and back into another device. Maybe this can be part of the system. I don't like Flatpak myself, but this is surely one benefit of it.
Okay. I have one question myself. While the OAuth seems to be a good replacement for the Cabros part, allowing me to figure out if someone is really someone, it doesn't seem to be very good at transporting the group information. Like, what am I allowed to do? Is there anything sort of standardized that could be used across services?
No. Yeah. There's nothing standard. The standard is what I am designing here with the WebIDEM Open API specification. This is the first. This is the first standard around for this, and so it's not much of a standard. It's proprietary with possibilities to become a standard, but that's why WebIDEM can transform using a JQ program any backend into. I had a demo last year, where I successfully transformed the user and group information from GitLab into the schema used by WebIDEMD and could use get and paste passvd to list all GitLab users on my system. So, yeah.
Okay, so thanks again, Nick, and we'll be back in around 10 minutes with Evangelos. See you soon.